In this video, we're going to look at conditional distributions. Definition. A conditional distribution lists the relative frequency of each category of the response variable given a specific value of the explanatory variable in a contingency table. So for each value of an explanatory variable, we're going to find the relative frequency of the response variable, and that gives us the conditional distribution. Let's take a look at an example. Example. Using the information below, find the conditional distribution of employment status by level of education. What is the association between level of education and employment status? Draw a bar graph that represents the conditional distribution of employment status by level of education. So if we start with part A, we want to find the conditional distribution of employment status by level of education. So for each outcome for level of education, we want to find the relative frequency for employment status. In other words, we want to find what is the relative frequency for employed, unemployed, and not in the labor force for individuals who did not finish high school. We want to find the relative frequency for employment, unemployment, and not in the labor force for individuals who were high school graduate. We want to find the relative frequency of employed, unemployed, not in the labor force for individuals with some college. And we want to find the relative frequency of employed, unemployed, and not in the labor force for bachelor's degree or higher. So, in order to find the relative frequency for this category of level of education, we're going to take each of the frequencies for each of the employment statuses and divide by the total. So for the relative frequency here, we're going to divide 9,607 by 21,839. So doing that, 9,607 divided by 21,839, that is about 0.440. So this would be the relative frequency of individuals who did not finish high school who were employed. To find the relative frequency for unemployed, we're going to take 570 divided by 21,839, and that is 0.026. And we're going to take 11,662 and divide by 21,839, and that is going to be 0.534. So if we add those up, that should add up to 1, except perhaps because of rounding. So again, what's that telling me? If we focus specifically on the people who did not finish high school, about 44% were employed, about 2.6% were unemployed, and about 53.4% were not in the labor force. Now we're going to do the same thing for high school graduate, the same thing for some college, and the same thing for bachelor's or more. So for high school graduate, we have a total of 62,325,000 of those, so we're going to divide each of these by that. So 34,625 divided by 62,325, that is approximately 0.556. So this is the relative frequency of employed if we're looking at this condition of high school graduate. 1,274 divided by 62,325, that is about 0.020. 26,426 divided by 62,325, that is about 0.424. So again, this is the relative frequencies of the category high school graduate. So about 55.6% of high school graduates were employed, about 2.0% were unemployed, and about 42.4% were not in the labor force. Look at some college. Doing the same thing. 36,370 divided by the total, 57,401. That would be about 0.634. 1,170 divided by 57,401. That is about 0.020. 19,861 divided by 57,401. That is about 0.346. So again, what does this mean? If we're looking at the condition, some college, then about 63.4% of people with some college were employed, about 2.0% were unemployed, and about 34.6% were not in the labor force. Do the same thing for bachelor's degrees or higher. So 57,102 divided by 79,248, that is about 0.721. So that is the relative frequency. 1,305 divided by 79,248, that is about 0.016. 20,841 divided by 79,248, that is 0.263. And again, I didn't mention it. These should all add up to 1, except perhaps because of rounding error. So what does this mean? Well, for individuals with bachelor's degree or higher, so for this condition, about 72.1% were employed, 1.6% unemployed, and 26.3% not in the labor force. So this is our conditional distribution of employment status by level of education. So again, what we're looking at is a distribution of employment status for each level of education that we have. Well, so what? Take a look at B. What is the association between level of education and employment status? Well, take a look. For people who did not finish high school, about 44% were employed. But for high school graduates, about 55.6% were employed. For people with some college, about 63.4% were employed. And for people with bachelor's degree or higher, about 72.1% were employed. So it appears that as the level of education is increasing, so is the likelihood of being employed. In the same way, if you look at not in the labor force. So for people who didn't finish high school, about 53.4% were not in the labor force. For high school graduates, about 42.4% were not in the labor force. And for some college, about 34.6% were not in the labor force. And for bachelor's or higher, about 26.3% were not in the labor force. So what's happening here? It looks like as the level of education is going up, the likelihood of not being in the labor force is going down. And what about for unemployed? Well, those levels are staying actually relatively consistent regardless of the level of education. So for didn't finish high school, about 2.6% were unemployed. For high school graduate, about 2% were unemployed. For some college, about 2% were unemployed. And for bachelor's or higher, about 1.6% were unemployed. So again, we don't see much of a difference in unemployment status for the different levels of education. But we can clearly see that the likelihood of being employed goes up as the level of education goes up. The likelihood of not being in the labor force goes down as the level of education goes up. Part C, we want to draw a bar graph that represents the conditional distribution of employment status by level of education. So here I have drawn a grid for my conditional distribution. So along the horizontal axis, I have the different levels of education. So I have did not finish high school graduate, some college bachelor's degree. That is the different levels of education. And for each of these, I'm going to create a distribution for employment status. So I'm going to start by creating a legend that's going to represent each employment status. So we're going to have employed. We're going to have unemployed, and we're going to have not in the labor force. And I'm going to use a different color for each of those. So I'm going to use a green color for employed. I'm going to use red for unemployed, and I'm going to use blue for not in the labor force. So we have green, red, and blue. So for each level of education, I'm going to create a bar for each of these that represents the different employment statuses. So now for those who did not finish high school, the relative frequency of employed was 0.44. So I'm going to create a bar, and the height of that bar is going to be about 0.44. So this bar is going to represent employed. And then unemployed, the relative frequency was about 0.026. So that would be maybe like here. So that bar is going to represent unemployed. And then not in the labor force was 0.534. So 0.534 is going to be like this. So again, for employed, that's going to be this bar, so that's green. For unemployed, that's going to be this bar, so that's red. And for not in the labor force, that's going to be this bar, so that's blue. Now I'm going to do the same kind of thing for high school graduate. So for high school graduate, the relative frequency of employed was 0.556. So I'm going to make a bar that is 0.556. For unemployed, 0.02. So I'm going to make a bar for 0.02. And for not in the labor force, 0.424. And so again, I'm going to color those appropriately. So this bar is representing employed. This bar is representing unemployed. And this bar is representing not in the labor force. For some college, the relative frequency of employed was 0.634. So that's going to go way up here. Unemployed was 0.02. And not in the labor force is 0.346. So that's going to be around here. And so once again, this is employed, unemployed, and not in the labor force. And last but not least, for bachelor's degree or higher, employed, the relative frequency was 0.721, so I have a really tall bar there. So about like that. Unemployed was 0.016, so a short bar. And not in the labor force, 0.263. So about right here. And so once again, this is employed, unemployed, and not in the labor force. So now this isn't the prettiest bar graph that you've ever seen, but it does the job in terms of showing the conditional distribution. So for each condition for level of education, didn't finish high school graduate, some college bachelor's or higher, we can see the employment status, the unemployment status, and the not in the labor force status. So we can see those relative frequencies. And so what we can see here is, as you look at these bars, if you look at the green bars from left to right, they're getting taller, which is indicating that as the level of education is going up, so is the likelihood of being employed. And if you look at the blue bars, you can see them going down. As the level of education goes up, you can see that the likelihood of not being in the labor force is going down. And you can also see that the likelihood of being unemployed is staying relatively consistent across all of the different levels of education categories. So this is the idea of a conditional distribution. we can look to see if there's any kind of an association within the different categories of an explanatory variable. So in this particular case, our level of education is our explanatory variable, employment status is our response variable, and we can see that there seems to be an association between the explanatory and response variable.